Hello everybody, this is going to be your first classroom of the semester, and we'll only have to do it in 15-minute segments because that's all that we get on the free Screencast-O-Matic. So without further ado, let's get started on the sequences portion. So a sequence you may have seen before. This is a very straightforward sequence. It's 1, 2, 3, 4, 5, and it continues. Here's a different one. Okay, this one, not as obvious of a sequence, but it's still got a pretty straightforward pattern nonetheless. Here's another sequence, and of course we got this sequence as well. And these are the sequences we're going to be looking at today. Now, you might be thinking that sequences are just a collection of numbers that have a certain pattern to them. Well, it's actually a little bit simpler than that. Sequences are just a set of objects that follow a specific order, but the pattern is somewhat optional. So many of you might know that pi is an irrational number, and pi never ends. The numbers keep going off of pi, 3.1415, but then it keeps going. Okay, the numbers that make up pi form a sequence. Even though there's no pattern to it, the order is very specific. And while we might say that sequences could end, you could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then stop, you could technically call that a sequence. We're going to look at sequences that never end. Okay. Beyond that, the sequences might not even be numbers. Okay, so here's a sequence of shapes, and this one also follows a specific pattern. Here's a sequence of letters, the ones you might know. And then here's another sequence that is a little bit harder to figure out the pattern for, but there is a pattern nonetheless. But I want to reiterate again that a sequence does not have to have a pattern. It just has to have order to it. So for example, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, a pattern that repeats forever, is going to be different than 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1. Here's another sequence of shapes, and I want you to keep this one in mind. And let me just challenge this for you as a thought process for the week. What is the next shape in this sequence? Can you draw it out? And if so, what is the pattern? Maybe you might want to think about that in terms of if you were to describe to someone how to go about to the next pattern, how would you do it? Okay. Now, how do we define sequences? This is where it starts to get a little bit mathy. So let's start with this sequence right here. So you might say you understand the pattern here. Pattern might be that to go from one number to the next, you double it. Okay? That's great. That's actually the pattern as we go through it. You multiply by 2 from one to get to the other. And I apologize if my handwriting's a little sketchy. I'm using a mouse here, so but that's the general pattern right here. Let's clear that. Now, one question that might arise is, what could be the next number or the next iteration? Okay. When you see this word iteration, don't be intimidated by this. All this is saying is just what is the next step. Okay. So iteration means step along the way. All right. So for this problem right here, you can say, what is the next iteration? And in order to do that, you might be thinking, okay, so what's the pattern? Okay, we're multiplying by 2. Okay, and where did we leave off? Well, we left off with 16. Okay, so in order to go from one to the next, we should just be following the same pattern, namely doubling the last sequence. So I think the next one will be 32. Okay. Another question that might be asked, and definitely a lot harder, is what is the nth iteration? Now, in math, when we say something like the nth iteration, what we're saying is, or what we're asking, is some arbitrary value. And by arbitrary, I mean just any value. Okay? So instead of, instead of asking for the next one, on this one I was asking for the 6th, right? When I said, what is the next one, I already have 1, 2, 3, 4, 5, right? 5 terms. I really wanted the 6th one. And you gave it to me just by repeating the sequence. But let's say I wanted maybe the 10th one. Okay? Or maybe the 100th one. See, I don't know how that guy on Kata Canada does it so well. My writing is a lot worse. Okay. Finding the 100th one versus finding the next one will be very difficult. Now, if I said that the next one was, or the previous one, the 99th one was, say, 100, you could very easily tell me what the next one is. But finding the nth iteration, just any one you want, just if I say, okay, give me the 10, and you give it to me. Okay, give me the 100th, and you give it to me. That is going to be a lot harder than finding just the next one. Okay? So that in mind, let's clear, and let's go forward. Okay. In order to do both of those things, we need formulas. Okay? And there are two formulas that you may already be aware of if you took Math 1 last year, the recursive and the explicit formula. Now, the recursive formula is basically only looking at the previous number or the last number that you have to get to the next one. So for example, if we had the one we had before, which was, let's say, 1, 2, and let's stop at 4, okay? If we knew that the pattern was to double the previous one to get to the next one, that is essentially what the formula is saying, okay? So the formula says, okay, just take the previous term and do something with it to get to the next term, okay? Now the explicit one, the explicit formula, is usually takes, and I'll say this, usually takes the initial iteration. Now the initial means the starting point, and it can spit out any iteration you want. So that's where you can, if you have the specific pattern down, you could find the 100th value or the 1000th value. All you'd have to do is plug in 1000, and you'd be good to go. Okay? So let's kind of see this in action. Before we begin that, though, I'd like to go through a couple of nasty variables here. So this is just using some sequence notation here. You might see a sequence like this. Now, I want you to ignore A0 for a second. Okay? Now, the way you say this is A0, A1, A2, blah, 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 all the way to AN. All right? You might also say A sub 1, A sub 2, or A sub n. That's totally fine as well. What these numbers are right here are what's called your index. Okay? That's this number right here is an index. This is just a placeholder for your sequence. And the reason why we chose A will come up later, but that is very specific to that sequence. So what I mean by that is if I'm looking at maybe a different sequence, I use a different variable. Okay? So if I'm talking about my A's, I'm talking about the values that come from the A set versus the G's, those are the ones that come from the G set. Now, the 0 index, at least for me, the one that we talk about here, you notice that I didn't color that one in. Those are the initial values. So I mentioned these before, and this is just definitions here. You don't have to, feel like this is too much here. I'm just giving these terms here to you. Okay? So these are the initial values. These are not technically part of the sequence, but they do help you out. So for example, if I gave you the set 1, 2, 3, okay, the sequence, then the first term is obviously 1, and the second term is obviously 2, and the third term is obviously 3, okay? And that's how the sequence goes, right? If I ask for the first term, you know what I mean. However, if I asked you for the 0th term, you can kind of figure out what I mean here. It's the term before the first term. And that number right here would be 0, the 0th term. Okay? Another example here, just so that we're clear on this, if you had the set going up by 3s, 3, 6, 9. Okay? The 0th term in this one is also 0. Okay? Because the pattern goes up by 3 each time. In order to get the 0th term, you would go down by 3. Okay? Hopefully that makes sense. And these things are important. These initial values are important for our formulas. But they're not technically part of the sequence. And I just want to make sure that this is absolutely clear. This formation of letters and numbers here is what we use in sequence notation. And the lower numbers are our indices or indexes or iterations. And the letters that they represent here are just referring back to that sequence. Okay? So let's do a couple of examples here. Let's see. Let's go back to the ones we had. Notice we had these 4 sequences, and we can build a column set here. Now, recursive, remember, if you need a little reminder what this means how do we get to the next term? The explicit is saying how do we get to any term? All right? So the first sequence goes 1, 2, 3, 4, 5. Well, what's the pattern? Well, you're just kind of going in normal order, going up by 1 each time, right? Okay, if I'm going up by 1 each time, then the recursive formula tells me what do I do to the previous term, in this case it's 5, to get to the next term. Okay? Let's kind of highlight this. Do I have a highlighter? That is a highlighter. Cool. Let's do that. Okay? What do I do to 5 to get to the next one? Well, I add 1 to it, right? And that's exactly what we're doing. To get to the next term, we take the previous term and add 1 to it. If I told you what the 10th term was, you could easily get to the 11th term just by adding 1 to it. Okay? So this is what the formula will look like. To get to the nth term, a sub n, take the previous term, which would have been a sub n minus 1, and add 1 to it. Hopefully that makes sense. Okay. All right, the recursive seems pretty straightforward, hopefully, as long as we get used to these nasty letters here. But what about the next one, the explicit? How do we get to, let's say, the 20th term? Well, this seems pretty easy, just because the iteration and the actual term are exactly the same. Namely, just take your 0th term and multiply it by the set you want. Okay? Now, in this case, I am including the first term here. Okay? Okay, I'm back. That was a weird cut. For whatever reason, it just kind of cut off. So, actually, I'm going to just adjust this slightly here. I don't want this to be a sub 0, so let me cross this out. I actually want this to be a sub 1, and see if you understand why. Gosh, this is really hard to write. A sub 1. Okay, here's why. In order to get to the 20th number, I need to take the first number of my sequence, in this case that is 1, and multiply it by whatever term I want, which is 20. Now, if I take my first term, which is 1, and multiply it by the term I want, which is 20, do I get the 20th term? 1 times 20 is 20. So I think that would be the 20th term. And you can write it all out if you're not sure, but that's the case. Okay, so let's cross this out. Now going on to the next one. Okay, so this was the doubling sequence here. 1, 2, 4, 8, 16. To get to the next term, we already said we multiply the previous term by 2. Okay, so if I wanted the, in this case, 6th term, I take the 5th term and multiply it by 2. That's exactly what this monster is saying right here. To get to whatever term you want, take the previous one and multiply by 2. Okay? So let's see if I got the next one right. Boom. Nope, still not right. In order to get this, for this particular problem, you again want this to be the g sub 1 term. Okay? So to get, I'm actually looking at this, it actually might be g sub 2. It is g sub 2. Okay. So this one is g sub 2. And, oh, by the way, there's lots of different formulas. These are just specific ones that I'm using. So in order to get to, let's say, the third term, we want to take the second term and raise it to that third power. Okay? Let's go to the next one. So the next one is actually a very famous sequence. It's called the Fibonacci sequence. Okay? And in order to get to the next term, you take the previous 2 and add them together. So 1 plus 1 equals 2. 2 plus 1 equals 3. 3 plus 2 is equal to 5. 5 plus 3 is equal to 8. And so on. Looks like I'm running out of time for this segment, so I will stop right here and continue on the next set.